By now you should understand that the massive ice sheets that covered Canada, New England, and New York just 18,000 years ago did not reach central Pennsylvania. Thus, the glacial deposits on which the soils of New York are developed do not exist here. We differentiate soils developed on transported material from residual soils, that is, soils developed in situ on bedrock native to a site. I've come to Penn State's agronomy farm with Ashlee Dere, a graduate student who teaches soil judging, to look at a residual soil and to introduce you to some of the aspects of field soil descriptions. Hey Ashlee.
Hi Tim.
What are you doing?
Trying to clear off some of this space here so you can get a good look at the soil pit and the cross section of the soil that's here.
Why is this pit here?
It's actually for teaching purposes. They've come out with a backhoe, and several places throughout the center county here they've dug out so we can look at what's underneath.
Well, I told the students that we'd have a look at a residual soil. I wonder if you could tell us a little bit more about what we're looking at here.
Here we've got limestone in the bottom of the soil profile. And all of this soil that you see in this valley that's being farmed, it's all forming from this rock as it weathers over the years. So it'll keep weathering, keep forming more soil, get thicker and deeper, but in this spot it just happens to be shallow. In other areas it's thicker.
So you mean all this soil here is derived from this rock?
Exactly. All of it is forming from what you see at the bottom. And as the years go on, it'll get deeper and deeper as more of this rock weathers and forms the soil.
Well, that's a great example of a residual soil.
It is. Makes for some very nice soil.
Well, why don't we go ahead and describe it so the students can see how a soil scientist describes a soil in the field.
All right. I want to make sure we get the profile wet enough to see color differences. Look for the different horizons now. Soils tend to form in different layers. And we can describe each of those layers to get a big picture idea of what's happening in the soil, how it forms, and what we can do with it. So now you can see it was dry before, but now we have more striking color differences now that we've gotten the soil moist. So now we need to figure out where these distinct horizons occur. We have a measure that in centimeters, but look at where we see differences as the soils tend to form in different horizons and each have different properties that we can describe, and that'll help us get the bigger picture of the soil. So color is the most obvious difference of horizons. So here it's pretty clear now that we've moistened it.
Yeah, I can see an obvious change from this upper brown layer down into a redder or orange here at about 24 centimeters, and then another change at about 40. And then down here obviously at 63 at the limestone.
Yep. And then down here we just assume, although we haven't dug any farther, and really we can't because there's just rock here, we assume that whatever we see down here extends to 150 centimeters.
So I'm going to go ahead and start filling out this log form, but maybe you could just briefly explain it for the students.
Okay. We have this form just to help document what we see, and we use a series of symbols. Really, they're just abbreviations for different properties, and systematically go through and piece by piece define these horizons and describe each of them. And in the end, we have this documentation of what the soil looks like, so anyone can go back who's familiar with this process, simply look at this sheet and get a mental picture of what is there. So it's really handy just to keep track of everything and for future reference, and it becomes a kind of language that explains what we have here.